Welcome to Castified. Today, we're diving into something really exciting that's got the astronomy world buzzing. A brand new, super fast interstellar visitor has just popped up in our solar system. Now, you might think, okay, another one. But these events are actually incredibly rare. I mean, really rare. This is only the third object like this we've ever spotted coming from beyond our solar system. It's a big deal. So, our mission today is to unpack what we know so far about this mystery object. What can it tell us? Why all the excitement? Let's explore.
It really is remarkable. And the key thing here, I think, is that this isn't just, another space rock flying by. This is a chance, a really unique chance to study pristine material, stuff that hasn't been altered, basically raw ingredients from an alien solar system.
Wow, pristine material.
Exactly. Think about it. We get insights into how other worlds form, their chemistry, the building blocks, without sending a probe light years away. It's like the universe mailed us a sample.
Like cosmic special delivery.
Pretty much. It's a huge opportunity to peek into how completely different star systems might have formed.
That's a great way to put it. Okay, so let's get the basics on our new guest. When and how did we find it?
It was spotted pretty recently, actually, July 1st, 2025. The discovery came from the ATLA Survey Telescope down in Chile, which is funded by NASA.
Right, ATLAs. And it has one of those slightly complicated names.
It does. Officially, it's 3I8. You might also see it called C2025N1, ATLAS.
Okay, 3ILAs. What's the 3I part mean for us?
Yeah, the 3I is simple but really important. It just means it's the third interstellar object we've identified. I for interstellar. When we first saw it, it just looked like another faint speck, maybe a near-Earth asteroid. Nothing too unusual initially.
If obviously something changed.
Oh, absolutely. As soon as astronomers got enough observations to plot its path, its trajectory, and crucially, its speed, well, it was immediately clear this thing wasn't from around here. We're talking about a hyperbolic orbit. That means it's not bound to our sun. It's just passing through on an open path.
For the speed you mentioned.
Incredible speed. Around 240,000 kilometers per hour. That's about 60 kilometers per second.
60 kilometers a second. That's hard to even imagine.
It is. Fast enough to cross the U.S. in under a minute, like you said earlier. And that extreme velocity, that's the smoking gun. Our sun's gravity just can't accelerate something that fast from within the solar system. And no encounters with planets could explain it either. It's just moving too quick to be one of ours.
So it came from interstellar space. Do we know where, roughly?
Well, that's another interesting part. Its path is different from the first two interstellar objects. This one seems to be coming from the direction of the galactic center, specifically near the constellation Sagittarius.
The galactic center. Okay. Why is that significant?
It suggests it might have originated in what astronomers call the thick disk of the Milky Way.
The thick disk, not the thin disk where we are.
Exactly. The thick disk is an older population of stars. And the implication there is pretty profound. Objects from that older region might have, well, different chemical compositions, maybe more pristine stuff, maybe richer in ice and water, or different heavy elements compared to things formed out here.
So it could tell us about how planets formed differently or earlier in the galaxy.
Precisely. It's a direct sample, potentially, from a different galactic neighborhood and maybe even a different era that could really shake up our models of planet formation.
Wow. Okay, so it's not just another visitor. It's potentially a very different kind of visitor, a sample from the old neighborhood, so to speak. To really get a handle on this, we should probably compare it to the others we've seen, right? 1I Oumuamua in 2017 and 2I Borisov in 2019. How does 3I Eklis compare?
Good question. The differences are quite striking. First off, speed, like we talked about. 60 kilometers per second for ATLS. Oumuamua was much slower, around 26 kilometers, and Borisov was about 32 kilometers. So ATLS is significantly faster.
And coming from a different direction, too, you said.
Right. Totally different direction in the galaxy. That speed and direction alone hint at a different origin story. But then you look at its physical properties, its behavior, and that's where it gets really unique. Its light curve.
The light curve, that's how its brightness changes as it spins.
Exactly. And 3I Atlas has what they're calling a notably flat light curve. Its brightness barely changes less than 0.2 magnitude over almost 30 hours of observation.
Flat. So not like Oumuamua then. I remember that one varied wildly.
Not at all like Oumuamua. Its brightness changed by like 3.5 magnitudes, hugely dramatic. That's what led to all the speculation about its weird shape, maybe cigar-shaped or pancake-shaped or tumbling end over end.
Right, the alien spaceship headlines.
Well, yeah, that too. But 3 Atlas isn't doing that. It's much more stable. Suggests maybe it's more spherical or at least rotating in a much more regular way.
Interesting. So less dramatically shaped, perhaps. What about activity? Is it like a comet with gas and dust, or more like an asteroid?
That's another difference. Its cometary activity is described as faint or maybe very weak. Astronomers are seeing some signs of a coma, that fuzzy halo comets get when ice turns to gas, but it's definitely not a strong one.
Not like Borisov. Wasn't that one clearly a comet?
Oh yeah, Borisov was unmistakably an active comet. Clear outgassing, dust tail, bright coma, the works. 3A Eddels is much more subdued. Now, that faintness could mean a few things. Maybe it just doesn't have much ice left, or maybe it's so big that the activity is spread out and looks weaker. We're not sure yet.
Okay. And its color. Anything revealing there?
It does share one trait with the others. It shows a moderately red spectral slope.
Meaning it looks reddish.
Basically, yeah. When you break down its reflected light, it's redder than, say, a plain gray rock. This reddish color is pretty common for objects in the outer solar system and interstellar space, too. It often suggests the surface has complex organic molecules, maybe formed by radiation over long periods. Tholins, they're sometimes called.
So it could have a surface like Oumuamua, or maybe the faint coma is just messing with the color we see?
That's the question, yeah. It could be an Oumuamua-like surface, or the coma could be subtly masking what the core, the nucleus, really looks like.
Wow.
We need more data.
In size, you mentioned it might be bigger.
That's the current thinking. The estimates are still preliminary, of course. But if you assume it's asteroid-like, the radius is maybe around 10 kilometers. Now, it almost certainly has a coma, which complicates things. But that 10-kilometer figure, that could make it an order of magnitude larger than 2I Borisov.
An order of magnitude, so like 10 times bigger.
Potentially, yes. Borisov was estimated around 1 or 2 kilometers across. If ATLAS is closer to 20 kilometers across, 10-kilometer radius, that's a whole different ballgame. It means we're suddenly studying a completely new size range for these interstellar visitors. We get to see what the bigger ones look like.
Wow, 10 kilometers or more. That's substantial. Okay, so it's different, it's potentially huge, but it sounds like time is critical here. I saw a quote from Chris Lintott at Oxford saying something like, "We want to get observations as quickly as possible because right now the object is pristine." What does pristine mean in this context?
It means pretty much what it sounds like. Unaltered. As it gets closer to the sun, it's going to get heated up. Baked, essentially. That solar radiation, the heat, it'll start changing the surface, maybe boiling off more ices, increasing the activity. Its composition could change.
So pristine means before the sun cooks it too much.
Exactly. Right now, before it gets too close, is our best shot to see it as it was out in interstellar space, to preserve those clues about where it came from before they get, well, erased or hidden by more outgassing.
And when is that closest approach?
Its perihelion, closest point to the sun, will be around October 30th. It'll get to about 1.4 astronomical units from the sun.
1.4 AU, that's just inside the orbit of Mars, right?
That's right. So, yeah, the clock is definitely ticking to get these pristine observations before late October.
Okay, it's getting relatively close to the sun, moving super fast, potentially large. But let's address the obvious question. Is there any danger to Earth? Any risk at all?
Absolutely not. Zero risk. The answer is a resounding no. Even though it's fast and maybe big, its path keeps it well clear of us. It'll stay at least 1.6 astronomical units away from Earth.
1.6 AU, that's what, about 150 million miles?
Something like that, yeah. Way outside our orbit. So no threat to Earth whatsoever. Everyone can relax on that front.
That's good to hear. But observing it must still be tough. You said it's faint right now.
It is pretty faint, yeah. It's around magnitude plus 18. That's quite dim, even for large telescopes. And it's moving very quickly across the sky, which makes tracking it a challenge.
So it requires some serious telescope power and coordination.
Definitely. But there's a bit of good news, maybe even for amateur astronomers listening. While it's faint now, if it does become a more active comet as it nears the sun, if that outgassing really picks up, it could brighten quite a bit. Some predictions suggest it might reach magnitude plus 11 by late October.
Magnitude plus 11, that's still not naked eye, but...
Yeah, but potentially visible with decent backyard telescopes, mid-sized ones. That would be amazing, a chance for lots of people to potentially see an interstellar object.
That would be incredible. And what about the pros? What's their viewing window like?
Okay, so ground-based telescopes should be able to observe it well through September. Then, around perihelion in late October, November, it'll be too close to the sun in our sky, what we call low solar elongation, basically lost in the sun's glare.
So a blackout period around its closest approach.
For Earth-based viewing, yes. But the hope is it will reappear and become observable again by early December as it starts heading back out. That gives us a second chance to see how the sun might have changed it.
It's fantastic that amateurs might get a look. So, okay, no danger to Earth, but immense scientific value. What makes 3i Attila so important beyond just being fast and maybe big? How is it changing the game?
Well, I think it genuinely represents what we might call a new class of interstellar object, and that's a big statement. If you look at the numbers, astronomers estimate its spatial number density. That's basically how many objects like you'd expect to find in a certain volume of space, like a cubic astronomical unit.
Okay, how common is it?
The estimate for 3i ATLAs is incredibly low, around 10 to the minus 3 per cubic AU, so 0.001.
And how does that compare to Oumuamua and Borisov?
Their estimated density was much, much higher, around 0.1 per cubic AU. That's like 100 times more common, roughly speaking.
Wow, 100 times difference. So Oumuamua and Borisov types might be relatively common, but ATLA's types are super rare.
That seems to be the implication, yes. It suggests there isn't just one type of interstellar wanderer. There might be completely distinct populations out there. It really challenges our models. We thought we had a handle on how many of these things might be floating around, but maybe the interstellar medium is far more diverse than we realized. ATLA's types could be the rare whales among more common fish, maybe?
That's a fascinating way to think about it. And even though it's rare, and we can't track it back to its home star.
Right, we probably can't. It's likely been wandering for billions of years, ejected long ago. Pinpointing its exact origin star is almost impossible. But that doesn't diminish its value. It still offers this unique chance to directly measure the properties of something formed entirely outside our solar system. We get to analyze material from a different stellar nursery, test theories about planet formation under different conditions. It's direct chemical analysis of an alien environment delivered to our doorstep.
And seeing the response. It's just amazing how the whole astronomy community jumps on these things. You mentioned ATLA is finding it, but then telescopes all over the world immediately started follow-up observations, right?
Oh, instantly. It's a fantastic example of scientific collaboration. You've got the Zwicky Transient Facility, Canada, France, Hawaii Telescope, Las Cumbres Network, Lowell Discovery Telescope, even European Space Agency telescopes.
Yeah.
Everyone sharing data, coordinating
A
observations.
global network, basically.
Exactly. A global network trying to squeeze every bit of information out of this fleeting visitor before it disappears back into the dark.
And presumably, we'll get better at finding these.
We hope so. New facilities are coming online, especially the Viracy Rupin Observatory in Chile. It's designed to scan the sky incredibly quickly and deeply. The expectation is that Rubin and other new tools will seriously increase the discovery rate of interstellar objects. We might go from finding one every few years to finding, well, maybe several a year or even more.
That would be incredible. More samples arriving.
It would transform the field. But for now, with 3i Atlas, the focus is intense observation. We need continued photometry measuring its brightness very precisely to understand its spin and changes. We need spectroscopy breaking down its light to figure out its chemical makeup, what elements and molecules are there, especially in any coma. And polarimetry studying how its light is polarized can tell us about the dust grains. All this helps understand its rotation, its activity, any non-gravitational forces pushing it around due to outgassing.
And you mentioned that tricky period when it's near the sun and hard to see from Earth.
Right, that perihelion passage. Earth-based views will be limited. So there's a really exciting push now to see if nearby spacecraft can observe it then.
Spacecraft, like Mars orbiters.
Exactly. Missions like NASA's Mars Reconnaissance Orbiter or MAVEN, maybe even ESA's JUICE spacecraft heading to Jupiter if the geometry works out. If they could observe 3i Atlas when it's closest to Mars, especially during that period we can't see it well from Earth, the data would be absolutely invaluable, seeing how it behaves right as it gets cooked by the sun. That's the gold standard.
Wow, using our Mars probes as interstellar object observatories, that's thinking outside the box.
Needs must. It's a unique opportunity. You have to use every tool you have. #outro.
So there we have it, 3A Atlas. It's clearly not just another blip in the sky. It's a rare cosmic messenger, quite different from the others we've seen, faster, maybe much larger, offering this fleeting, amazing glimpse into the universe beyond our own solar system.
Absolutely. And the opportunity it presents is just profound. By studying this object, we're literally unlocking clues about how worlds formed, maybe billions of years ago, around stars completely unlike our sun in different parts of our galaxy. It's a direct look at the raw ingredients of other star systems and the nature of interstellar space itself. It helps us understand the context for our own solar system's formation.
It really makes you think, doesn't it? If our solar system is just one tiny corner of this vast galaxy, and we've now spotted 3 visitors just passing through, what else is out there? What other kinds of incredible, bizarre, maybe even informative objects are wandering between the stars, just waiting for us to find them? And how will those future discoveries keep changing how we see the cosmos, and maybe even ourselves? Something to ponder. Thank you for joining us on this deep dive.